So today we are talking about transformation of parent functions. Okay, this is our second day on this, so we're going to push a little bit further, and we're going to talk a little bit more about the absolute value as a transformation versus the absolute value as a parent function. Okay, so we're going to start off with this one. Y equals negative x plus 2 squared plus 3. All right, so let's start off by deciding the parent function. What's our parent function? Great. Y equals x squared. Let's think about what the graph of the quadratic parent function looks like. Okay, it's a U. We call it a parabola. Okay? For these three examples, and for your homework and tests and quizzes from now on, you're going to be plotting 3 to 5 points. Okay? On parabolas, it's always going to be 5 because it's like your 3 in their mirror. Okay? Square roots and stuff like that, you can do 3. Okay? So what would those 5 points that we're going to transform be? What are those 5 first easy points? 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. All right, so these are the points you're going to be transforming today. Okay? Let's list the transformations that are going on over here. Left 2. That's the first thing we're going to do. Why is it left 2? Yeah, it's inside the parentheses. It's affecting our x, so it's opposite what we think. Okay? Then what? Reflect across the x-axis. The negative is outside of our function, so it's changing our y's. So that's why we reflect across the x-axis. Okay? And our last one. Up 3. Okay, would you please take a few moments and graph this function? Okay, if you need to do it in stages, that's fine. If you can do it all at once, that's fine too. Make sure you plot those 5 points. I need to know where those 5 points moved. Those are the 5 points we're going to use. Pretty much. Okay, does everyone have theirs? Your 5 points? Look up here to check your graph. Your 5 points should have become negative 4, negative 1, negative 3, 2, negative 2, 3, negative 1, 2, and 0, negative 1.
Yeah, but
It is a reflection across the x makes it go from an upwards to a downwards. Okay? So first you move left 2, and your parabola is... Oh, okay. Yeah, you have to reflect. I mean, you have to go left 2 first. Other questions on how I got this? Okay. The next thing we're going to do is the absolute value of that same graph. Okay? We're going to take that whole function that we just started with, and we're going to do the absolute value of the whole thing. Right? Now, look closely at this equation. Y equals the absolute value of negative x plus 2 squared plus 3. What is the parent function here? Yes, it is still y equals x squared. Even though there is an absolute value in here, there's another parent function. That parent function is x squared. If, when you're looking at an equation, you see another parent function and an absolute value, you're going to treat absolute value as a transformation, not as a parent function. Does that make sense? Okay? If there is another parent function, absolute value becomes a transformation, not a parent function. Okay. So, let's talk about these absolute value bars. These are the same as when we talked about our rule. We had the absolute value of f of x. That's because it's on the outside of our function. Everything is included. Okay? What was our rule when we were taking the absolute value of the whole function?
Negative x's.
Okay? So what do we do with positive y's? Let's start there. Keep the positive y's. We're going to keep positive y's. What are we going to do with our negative y's?
reflect across the x-axis.
Reflect across the x-axis. Reflect negative y's across the x-axis.
That's going to be for guided study. And I told everybody to bring it to this room.
On the email it says 220. I'm happy to do it.
No.
Okay.
I want to put it wherever I said.
Okay.
I just don't know where I said. I thought this was 220 if you want to know the truth.
Okay, sorry about that.
Silly goose.
Okay, so we're going to do everything else first. The absolute value comes at the very end. Okay? So we already did everything else though, right? We did on number 1. Absolute values are always going to come at the end. Alright, so if you would please re-sketch the graph you drew in number 1. Okay, with your points. Re-sketch the graph you drew on number 1. Make sure you know where those points are. We're going to apply the transformation to that. So yeah, I would re-sketch it. This is an extension. If you have a different color, you might want to use it for this next part. You're redrawing your graph from number 1. Okay? Now, we luckily had already done all those transformations before, but say you got this problem just to start with, you would list your transformations, do them all, and then the absolute value would come at the very end. Okay? So, we're going to follow our rules. And our new graph, I'm going to do it in green. Okay? Our first rule says keep the positive y's. Okay? So that means that all my positive y's are going to stay a part of my new function. here. This part is going to go up to here, and this whole piece is getting flipped up. Okay? The way you want to think about this, okay? The way you want to think about this is if you had your original graph on, say, a sheet, like a clear sheet, maybe a transparency. You remember those things from way back in the day? Okay? You had this graph on a transparency. You would fold it right along the x-axis. Okay? You'd fold it right along the x-axis, and you'd fold it together. Whatever was all in this top part, that's your graph. Okay? Because it would kind of like overlap. Can you picture that? If you had a transparency, it would kind of like overlap on top of it. Okay? Questions about the absolute value of f of x? The absolute value of a whole function. Okay, now let's try one where the absolute value is just around the x. And then we'll be done. The absolute value of x plus 2, that whole quantity squared, and then plus 3. The absolute value is just around your x this time. Okay, even though we see an absolute value, what is our parent function?
X squared.
Good. Still y equals x squared. Okay? Remember, the absolute value is only your parent function if you don't see any other parent function. We see one. We see x squared. Okay. Even though the absolute value is on the inside with the x, we're still going to do it last. Okay? Because we have to know how the graph acts first. The absolute value is going to come at the very end. So that means we have to apply all the other transformations, which we already did back in number 1. So what do you think you should do? Reschedule. Go for it.
Wait, so we start with the first graph?
Yeah, go back to the first graph with no absolute values. That's what we're going to apply this absolute value of x to. Does everyone have it through sketch? Okay, let's talk about our rule here. Okay, this is like f of the absolute value of x. F of the absolute value of x. Now let's think back when we talked about transformations. What did we learn about that?
Throw out negative x's.
Good. Throw out negative x's.
Thanks, Trey. Wait, no.
Throw out negative x's.
No.
Okay, so we're going to keep our positive x's. And then what with them? Reflect them across the y-axis. Okay? Okay, let me explain one more time why this works. Okay? We throw out the negative x's, and then we reflect the positive x's to take their place. Okay? Let's think about why that works. What happens if I plug in a negative 1 right here? What does it automatically become? Positive 1. Okay? So automatically, instead of acting like a negative 1, it's going to act like a positive 1. Okay? That's why negative 1 and positive 1 have to have the same y value. That's why we're going to reflect leave them and sketch your new graph in a new color. Either one is fine. You just throw them out. Okay? Then we keep our positive x's. Our positive x's stay. And then what do we do with them?
Reflect them across the y-axis.
Reflect them across the y-axis. That's our final graph.
Wait, it's just the left side?
Nope, it's everything in green. Everything in green is the final graph. Okay? Other questions? What do we do? Okay. We got rid of all these negative x's. Throw them out. You keep the positive x's, so you keep them. And then you take the positive x's and flip them over the y-axis. So your final graph is the positive x's and the reflection. All right, any other questions? Cool. Okay. Yeah. What is this transformation called? The absolute value of x. Is that what you're asking? Or are you asking how you would write it down? How you would write it? Like if I ask you the transformation, you would say reflect positive x's across the y-axis. That's what you'd say. Okay?